So this is the second part of our volume by revolution work. So this is just a quick reminder of what we're looking at. When we're rotating horizontally or relative to the x-axis, so that would be if we had a curve that looked like this and we're rotating horizontally. So we get these kind of vertical looking circular cross sections. We have our equations here for finding the volume. Both of them are derived from the circle equation, pi r squared. We just have to subtract the axis of rotation from our functions, our radius functions. When we've got one curve, it's just one value squared, and when we've got two curves, it's the difference of the outer function squared and the inner function squared. These are in terms of x, right? When we switch to talking about the y-axis, or horizontal rotation, right? So that would be if we had a curve and we rotated it this way, right? We'd get horizontal cross sections. We are going to be doing everything in terms of y. So that means, whoops, we're going to look at C and D instead now, which are going to be y values. We're going to have our radius functions in terms of y. So if we're thinking about a normal equation down here, instead of y equals, those would be x equals, and the functions we'd be plugging in here would be in terms of y. So if the first one here would be x equals square root y, and then you'd have square root y inside of that integral. What we're going to do in this video today are look at some of the problems where we rotate two curves around an axis, around a line that is not the x or the y axis. So I'm going to do those kind of different flavor of problems, all right? And I'll leave the just straightforward around the axis problems, and then one around a horizontal or vertical line problem for you guys to try. So this is just around the x-axis, so that one's going to be left for you. This one's about the line y equals 4. So that's a horizontal line, all right? So if we're horizontal, that means we're going to be looking with respect to x. Mirror. Eraser's not working today. All right. All right, so let's draw our line. Y equals 4. We're rotating around that. So that means that we'll have the mirror image up here. So it'll look something like this, all right? And we'll have circular cross sections on that volume. I'm not going to claim that my graph is perfect, all right? But these have now rotated around here. So we've got an inner circle and an outer circle being formed. And we'll talk about that in just a moment. So let's label our functions. I've got my parabola here, and that's going to be x squared. So our parabola here is x squared, and this line was x plus 2. So when we're looking at this now, we're saying, okay, which one's further, which ones are outer, further from that axis of rotation, and which one's closer? So if we're looking at this, the further curve is going to be x squared. It's the one that's furthest from y equals 4. So r of x, my outer, is going to be x squared. My inner, lowercase r of x, is going to be the one that's closer to my axis of rotation, y equals 4. That's x plus 2, so that's my inner. I have to determine my bounds, so we're doing with respect to x, so we're looking at the x's where this volume ends. It's -1 and 2, so it's like my a and b. And then I go ahead and set up my volume equation. So for two curves, so our area from a to b, so from -1 to 2 of our first function minus our axis of rotation squared, right? That's our outer function. And then we've got our inner function minus our axis of rotation squared, all right? So what we're going to have to do here is we're going to have to FOIL, all right? If you need to do those steps out, that's, oopsie, that's fine. All right, but I know you guys are all capable of that, so I'm just going to write out the expanded form here. So we've got x to the 4th minus 8x squared plus 16 minus, using parentheses here, so I'm going to remember to distribute that negative to all terms. So I've got x squared minus 4x plus 2. So when I distribute that negative, I'll have minus x squared plus 4x minus 2. All right, whoops. And now that we have that, we're going to go ahead and combine our like terms. All right, just give me a second to write this out. So we've got pi times our integral from -1 to 2. And then we've got x to the 4th. -8x squared minus x squared is -9x squared. Then we've got just 4x. There's no like terms for that. And then we've got 16 minus 2, which is going to be 14. All right. Now that we've combined our like terms, we can integrate using the power rule and the constant rule. So I'm going to increase my exponents by 1 and divide by the new exponent. And for a constant, you just add the variable you're integrating with respect to. All right, we can simplify this. So let's go ahead and do that. And then we're going to have to substitute in our values. Two and -1. So I'm going to have pi times 2 to the 5th for 5 minus 3 times 2 to the 3rd plus 2 times 2 to the 2nd plus 14 times 2. That's going to be minus -1 to the 5th over 5 minus 3 times -1 to the 3rd plus 2 times -3 squared plus 14 times -1. Oh, I'm sorry, this is a -1 here. Oops, I don't know how I got to -3. All right. So let's do some math. We've got 2 to the 5th, 32. 2 cubed is 8 times 3 is 24. 2 squared is 4 times 2 is 8. 14 times 2 is 28. Over here we have -1/5. -1 times -3, +3. Negative 1 squared is positive 1 times 2 is positive 2. And then 14 times negative 1 is negative 14. All right, before we start playing with the fifths here, let's just combine some stuff. So we've got 3 and 2 is 5, and negative 14 is 9. All right, I'm going to want that to be over 5, so I multiply by 5 over 5. Then up here, what do we have at the head of the bus? The head of the bus, we've got 28 and 8, which is 36, minus 24, which is 12. That's 5 over 5. All right, we're getting there. Now we're cooking with gas. So we've got 32 over 5 plus 60 over 5 minus negative, so it's going to be plus a fifth, plus 9 times 5, 45 over 5. All right, I got 32 and 60, which is 92 plus 1, 93 plus 45, so that's going to be, what did I say, 93 plus 45, 138 over 5 times pi. And we're finally at an answer. So that's our around two curves around a horizontal line, or a y equals line. All right, so it's a little bit drawn out of a process, but that's how we get it done. So go ahead and try the other two problems that have us rotating around a horizontal line or around the x-axis.